Learn VR MR. Come to the Spatial XR community.
Now, I am entering Unity to apply the theoretical knowledge introduced earlier to develop the object interaction function in the HIM-R environment. I will choose the Reality Kit rendering mode, so I need to import the Polyspatial development package. I have already imported it, and the related environment configuration is also set up. You can refer to the tutorial I previously made for the specific configuration steps. Let's open the package manager. And you can see that I have already imported the Polyspatial related development packages. In this tutorial, I am using the Polyspatial 2.0 version. But the content I am introducing here is also applicable to versions before Polyspatial 2.0. So you don't need to worry about the Polyspatial version. After importing Polyspatial, we need to go to Edit Project Settings and find Apple Vision OS. Set the app mode to Reality Kit with Polyspatial. If you are using a version before Polyspatial 2.0, the corresponding mode should be MR mode. After importing Polyspatial, we will also import the XR Interaction Toolkit. We can click the Window menu, then Package Manager, and search for XR Interaction Toolkit in the Unity registry. Here, I can directly find the latest version of XR Interaction Toolkit in the Package Manager, which is version 3.05, and then click Install to install it. Of course, if you cannot find the latest version of XRI in your Unity version, you can import it through another method. We can click the plus sign in the top left of the Package Manager. Select Install Package by Name and input the name of the XRI package to import it. What is the name of this package? It's this string, and we can also find it on the XR Interaction Toolkit official website. You can search for the XR Interaction Toolkit on any search engine to find its official website. You can see that the latest version is 3.0.5. Click Installation to enter the installation page. Where you can find the name of the XRI package. Then copy it, go back to Unity, paste the copied name into the Install Package by Name field, and click Install. Here, I will directly install it from the Unity registry. Click Install. After successful installation, we will find the imported XR Interaction Toolkit in the In Project section of the Package Manager. It also has several examples that can be imported. Okay, there is also a dedicated example for Vision OS, which we can import and study the sample scene. After importing, we open the project settings. A pop-up window appears and we click Yes. Then, click Fix All in the Project Validation section to fix the configuration. After the import is successful, we can create a new scene and officially start the development process. Click Create Scene. Give it any name. And open it. First, create a volume camera in the scene. Right-click in the Hierarchy panel, select XR, choose Setup, and click Volume Camera to create a volume camera. I have previously made a tutorial to introduce the concept of volume camera in detail. If you are confused, you can refer to that tutorial. After creating the volume camera, we add the volume camera configuration file here. Since I am demonstrating the shared space MR application development, I will choose the bounded volume, which has boundaries. This configuration file is automatically added when we import the polyspatial sample scene. And it is located in the project folder. After configuring the volume camera, let's adjust its dimensions to make the visible range larger. Set it to 1 meter, and then right-click in the Hierarchy panel, select XR, and click the Interaction Manager. At this point, it automatically creates an XR Interaction Manager object in the scene, which has the XR Interaction Manager script attached. We mentioned earlier in the theoretical knowledge introduction that this XR Interaction Manager is responsible for managing all Interactor and Interactable objects. Next, we need to add the Interactor and Interactable needed for object interaction in the scene. Let's first add the Interactor for the interaction. We can create an empty object in the scene and name it SpatialInteractor. In the shared space, we cannot access the user's hand skeleton data. So if I want to implement a grabbing function, normally the interactor initiates the interaction with the hand. And the object that can be grabbed is the interactable. But at this point, I cannot determine the position of my hand because hand skeleton information is not available in the shared space. To solve this problem, Polyspatial has introduced a new input method called Spatial Input. This spatial input also has a corresponding interactor. We will add a script to this object called XRTouchSpaceInteractor. The XRTouchSpaceInteractor comes from the Polyspatial development package and is used to handle spatial input for the shared space. Spatial input includes 3 types: indirect interaction using ite-racking and gestures, direct interaction using pinch grab with thumb and index finger, and poke interaction using the index finger. The XRTouchSpaceInteractor is essentially an adaptation of Polyspatial for XRI. Because XRI interaction requires both an interactor and corresponding interactable. But in addition to this method, there is another way to handle spatial input. This other method requires a script from XRI, which is the reverse, meaning it's an adaptation of XRI for Polyspatial. This alternative configuration method may be slightly more complicated in operation. but its configuration process is similar to the development process required for VR applications and other XR device applications. Therefore, the alternative method may have more advantages in cross-platform development and also allows for more complex interactions using the scripts provided in XRI. I will introduce both methods. Let me first introduce the first method, which is using the XRTouchSpaceInteractor operation method. Its configuration process will be relatively simple. As we can see, there is a parameter on this script called Spatial Pointer, which needs to reference an input action reference of this type. The input action reference is actually a concept from Unity's input system. We can click the circle on the right to choose from some input action reference configuration files. Of course, at this point, you might feel a bit confused by these configuration files, but that's okay. Let's first find the input system configuration files provided by Spatial for MR development. These come bundled with the Spatial development package when imported. We can click on Assets, find Samples, then Spatial, and here we have an input maps. Okay, this file is the input system action configuration file prepared by Spatial. Okay, you can see that its type is input action assets. Input and actions are key concepts in the input system, because this new version of the input system separates the logic for actions and input. We only need to handle the binding relationship between input and actions in the input system configuration file. Now we can open this configuration file to see what it looks like. Okay, after opening, it looks like this window. Let's first look at the leftmost section, called Action Maps. Each row under Action Maps represents a different action input mapping set. And the right section shows the actions stored in each mapping set. Okay, the mapping set called Touch is the action configuration mapping that Spatial has prepared for us to handle spatial input. Let's take a look at these actions under this mapping set. We can click one of the actions and expand it. The next section of the action shows the input configuration bound to this action. The two actions we will need later are one called primary touch and the other called secondary wordhook. This is because in VisionOS's shared space, a maximum of 2 inputs can be received. But since we cannot obtain our hand skeleton data, we cannot determine whether the left hand or right hand is inputting. We can only determine which is the first input and which is the second input. The primary touch corresponds to the first input, and the secondary corresponds to the second input. The action properties on the far right allow us to change some parameters of the action. And the binding properties allow us to modify the input configuration. We can see that the current primary spatial pointer input is using an input from the spatial pointer disk. called primary spatial pointer. This input is under Other in the Spatial Pointer Device section. There's also a visionOS spatial pointer device here, which is different from the above spatial pointer device. The above spatial pointer device corresponds to the input for MR applications rendered by RealityKit, while the visionOS spatial pointer device corresponds to the input used in applications rendered with Metal. So their differences need to be noted. We will use the default configuration for this input configuration file. And these actions are actually equivalent to the input action reference, which we need to reference in the spatial pointer parameter. How do we reference the actions from this input configuration file here? We can note the name of the input. Click the small circle and input primary. Okay, that's the primary touch. Then we check if it is from the input configuration file under polyspatial. The safer way is to find and expand the input configuration file under polyspatial, then drag the action here to assign it. Okay, this way we ensure that it references the action defined in the polyspatial input configuration file. This action is now bound to spatial input, and we've configured the first spatial input. Now we can configure the second spatial input by directly duplicating this object. We can click it and quickly copy it. Then we modify the spatial pointer, because we just referenced the first spatial input, which is primary touch. In the input configuration file, the second spatial input is defined as secondary Werdic. Let's drag it here. Okay, that's the action for the second input. Now, the interactor related to both inputs in the space has been configured. Now that we've configured the XR interaction manager and the interactor for initiating interaction, the last thing we need is the interactable, which refers to the object that can be interacted with. Therefore, the XR development process is quite clear. And for most SDKs, we need both an interactor and a corresponding interactable to complete the XR interaction module. Now, let's configure the interactable. Before that, let's add some objects to the scene because there is nothing visible in the current scene. Let's first add a ground by searching for an object called platform. We can select this object and drag it into the scene, adjusting its position. This object is a platform model provided by polyspatial, and we can later place some objects on this platform for interaction. I will adjust its scale size. While adjusting, make sure the object is within the visible range of the volume camera, meaning it must be within the cube's range. Okay, that looks about right. Now let's add a box collider to this object so other objects can fall onto this platform. Of course, other objects also need to have colliders. Now, let's add an object that can be interacted with. I will still search for a polyspatial object called cube. Let's drag it over and adjust its size. Okay, that looks about right. And it should also be within the visible range of the volume camera. Next, we can modify the material of the cube. Let's create a material folder. Then create a new material, click Create Material, and create a white material. The default color of this material is white, so we drag it onto the cube. Okay, now the color of the cube in the scene has changed. Let's delete the mesh collider from this cube and replace it with a box collider. Next, for this cube object, let's remove its prefab. Okay, now let's create an empty object in the hierarchy panel to manage all the objects in the scene. We can call it Environment, reset its position, and make these two objects children of Environment. Now, when we drag the parent object, both objects will move together. Okay, now we need to add the interactable component to this cube. The collider is also necessary because if we want a spatial input to affect an object, we must ensure the object has a collider. Okay. After ensuring the collider is in place, we can add the interactable component required for interaction. We can search for Grab Interactable. And once we add the script, it will automatically add a rigid body, which is also necessary. We can choose whether or not we need gravity. If there is gravity, it will be affected by gravity and fall onto the platform below. If we don't need gravity, we can uncheck Use Gravity and check Is Kinematic. Then, if Is Kinematic is checked, we need to find a parameter in the Grab Interactable script called Throw on Detach. If your rigid body has Is Kinematic checked, it's best to uncheck this parameter. Although checking this parameter won't affect the program, Unity's console window will show some warnings during runtime. If you're a perfectionist, you can uncheck this parameter to prevent the console from displaying warnings. The XR Grab Interactable we just added, as the name suggests, is related to grabbing. Because our spatial input includes both indirect and direct interactions. Indirect interaction refers to grabbing an object at a distance using eye movement and gestures, while direct interaction refers to grabbing an object up close using a pinch gesture with the index and thumb. Therefore, we need this grabbing-related interactable. In addition, the spatial input also includes a touch input, which is equivalent to poking an object with a finger. This input also works with XR Grab Interactable. So, by adding the XR Grab Interactable to this object, we've configured the necessary interactable for spatial input. We can apply 3 different spatial inputs to this object. The XR Grab Interactable script has many parameters, and we will explain them in detail when needed. The throw on detached parameter we just configured allows the object to be thrown when grabbed. Applying some velocity to simulate the physical effect of the object being thrown. This throw on detached option has no effect on rigid bodies with is kinematic checked. If we want the object to have gravity effects, we need to check Use Gravity and uncheck Is Kinematic. And only then can we check the Throw on Detached option. After configuring the collider, rigid body, and XR Grab Interactable script on this object, it's essentially configured with the necessary scripts related to the interactable object. Now, we will add another script to the object to implement the hover highlight effect. We can search for a script called Vision OS Hover Effect. After adding the script, when we look at the object with our eyes, we will see the object highlighted. This interaction state when gazing at an object is called hover. If you are using a version of Polyspatial prior to version 2.0, this script will not have these parameters because in Vision OS 1.0, the hover highlight effect on objects couldn't be modified. However, in Vision OS 2.0, we can customize the hover effect. We can modify the type parameter of this script, which has 3 options. By default, it is Spotlight, which will cast a point light at the position where the object is hovering, illuminating it and creating a highlight effect. If we select Highlight, the brightness will be higher compared to Spotlight. If Shader is selected, we can use custom shaders to achieve the highlight effect. The color parameter below can be used to modify the color of the highlight effect. Since the object is white, the white highlight effect will be hard to see, so I'll change the highlight color to yellow. You can try other adjustments to see how these parameters differ and affect the result. Next, I will add a script to implement the shadow effect on the object. Polyspatial has also prepared a script for us called Vision OS Grounding Shadow. Once this script is added, the object will automatically have a shadow effect. And we will be able to see a shadow cast on the platform beneath it. Now, when you run the program, of course, you should have Unity's Play to Device streaming debugging configured, and click the Run button in Unity. The scene will be transferred to the Apple headset for testing, and you will see the shadow under the object. This is the effect of the Vision OS grounding shadow script. When you gaze at the object, the hover highlight effect will appear. Based on my own testing in my environment, the spotlight highlight effect appears a bit dim, so I changed it to highlight. The hover and shadow effects work well, but you might notice that your hand cannot manipulate the object. Even though we've configured the necessary interaction manager, Interactor, and Interactable, we still can't manipulate the object. This is because our interactor is referencing an input action from the input system. And the action configuration comes from the input action configuration file prepared by Spatial, which is this file. By default, this input system configuration file is not activated, and we need to manually activate it for the system to detect whether the input associated with the referenced action from this configuration file has occurred.